So since the definition of specific heat of water, and thank you for remembering that, whoever did, remember that the definition of like a calorie is the amount of heat required to raise the temperature of 1 gram of water 1 degree Celsius. If you remember that, and of course the other thing you have to remember is a calorie is 4.186 joules. That one's not so easy. That's not obvious, but yeah, okay. Anyways, what we're pretending here is that this is an insulator and no heat can go in or out. And so then you're gonna pour some amount of antifreeze into here, okay? And then I believe this water was at what temperature originally? Yeah, on the verge of freezing. So the temperature of the water is essentially 0 degrees Celsius. It's right there. You take out any more heat and bam, it's gonna start to freeze, okay? And they said room temperature water, or room temperature antifreeze. Is it 20? It's 20, right? Not 25, okay. So then, oh, they said 20. Well, that makes life easier. So 20 degrees Celsius antifreeze. Okay, so that's going to be the source of the heat. And then what you can do is you can say something like, the way I like to deal with these things is I usually deal with it like this. Heat lost equals heat gained. Okay? You can also deal with them by saying heat lost you can also say heat lost plus heat gained equals 0. There are different ways of looking at the same thing. I'm going to show you the way I usually do it because for me, I think it makes some sense. Heat lost equals heat gained. Who loses heat in this problem? Okay, now the music's getting irritating. All right. Goodbye, Mr. Flamenco guitar person. So who is losing the heat here? Otis. Well, you can take a look here. Who's losing heat? The what? The water. That's this is water. This is antifreeze. Okay? The antifreeze is losing heat. Does that make sense? And so, of course, then, Lisa, who's gaining the heat? The water. So, I just deal with this accordingly. The reason I always do heat lost equals heat gained is because whenever you do delta T, you just do hot minus cold. That's always the way you do it. So final initial, it's just hot minus cold, always. So the antifreeze loses the heat. So it's the heat of the antifreeze is going to equal the heat gained by the water. Okay? So then we can say the mass of the antifreeze, is that what they're looking for? Yeah. I'm going to do A instead of AF just to make life a little bit easier. So we're going to do the mass of the antifreeze times specific heat of the antifreeze times delta T of the antifreeze. And we're going to talk about the mass of the water times specific heat of water times the delta T of the water. Now, just to be clear, do you see that the TA initial is 20? What is TA final? Do you see it's 1.5 degrees? Right? Because that's what the final is supposed to be. And it's hot minus cold, right? And if we look at TW initial, that's 0 degrees Celsius. And TW final, that's 1.5 degrees Celsius. So delta TW is going to be 1.5 minus 0. So then, I'll go ahead and write that in. MACA, and that's going to be 20 minus 1.5, equals MW, CW, and that's going to be 1.5 minus 0. See, so if you write out all the temperatures And if you're looking for the final temperature, you just have to ask yourself, is it higher or lower, hot or cold, and you just subtract them. And of course, we're looking for the mass of the antifreeze, I think. So we say mass of the antifreeze is equal to mass of the water, specific heat of water, times 1.5, divided by specific heat of antifreeze, times 18.5. And just multiply that out and see what you get. What does that come out to be? 0.326 kilograms. So 326 grams. Questions?